good. I just want some random weird moments. Only thing that's off is ammonia is NH3. You just mislabeled them at the beginning. HCl is the acid. So they're going to do the opposite things. Yeah. Did I? No? You did it wrong. You're going to redo? Ammonia is NH3. The starting one, you have NH4. So that's going to change what your products are. So remember, ammonia is NH3, hydrochloric acid, we should know how to name. Anybody else want me to check? There you go. Just make sure that there's an arrow to connect them when you're writing them on a larger space. Okay. HCl, what is its formula? Or hydrochloric acid, what's its formula? HCl, right. Okay, hydro meaning binary, so we're dealing with chlorine with our hydrogen. Ammonia, all right, NH3, I would know that one for your quest, ammonia. That's the only weird word that we haven't used much, or it's not a weird word, but common name that I'll make you know for the test. Be able to recognize. Okay, so which one is the acid? Acid, the word acid should give you a hint that HCl is the acid, and that NH3 then therefore has to be our base. So our acid is going to donate an H+. It's just going to give it away to our beautiful base. So what is HCl going to become? Cl, and what does it need? -1, right? This HCl is technically an H+ and a Cl -1 that came together. So if it loses that H+, now it's just a Cl -1, right? Lost an H+, you can also think about it lost an H+, so we have a negative charge. And NH4, or dang it, I just keep giving away all the good stuff. But I didn't give away everything. NH3 is the base, so it accepts the H+, so what does it become? NH4 plus 1. Yes, gained an H+, we need a positive. All right. HCl is paired with who? Cl -1. These two are paired together. So Cl is our conjugate. Base. NH4 is our conjugate. Acid. Whoop, whoop. Cool. Any questions? None. 0. Oh, birds chirping, fresh air. It's a good day, guys. It is a good day. Birds chirping. We're talking. All right, maybe I made it sound a little better than it really was. Okay, if it stays around too long, it might get annoying. All right, I'm trying to think of anything else that I wanted to review with you guys. On the board, nope. All right, just kind of a preview for the quest. Obviously, like naming the acids, bases, and salts, writing the formulas for them, knowing how to do what we just did with the conjugate acid-base pairs. And then it'll also ask you if you know the definition of like an Arrhenius acid base and a Bronston-Lowry acid and base. So it'll ask you about those definitions, and then what we're about to do next, titration calculations. Ooh, ooh. So let me put my laptop on here so I can show you a picture, because it's really cool. But first, go ahead and turn in your books to page 173. We're going to talk about titrations. So go ahead and read what is written on page 173 while I get my laptop set up. That's okay. They can just fast forward through it. It won't be that long. Really? Where did you go? Just kidding, guys. False alarm. Okay. So titration involves a measured control amount of solution A. Okay, I don't like that definition. Just kidding. I'm not going to read that. Titration, the goal of it is we can either find out the molarity of we usually try to find out our molarity of our base, or we can measure the volume we're going to need. But the entire point is to reach this point called an endpoint, equivalence point, where an acid and a base are neutralized. Now, we briefly talked about pH scale last time. When we're between 1 and like 6-ish, what do we have if we're on the pH scale? Acid. All right, we have an acid. And acids have a greater concentration of H+, right? If HCl breaks apart in solution, it's going to have an H+. But here's one for you. While H+ is in water, it combines with the water to make what? It was, oh, what? Not OH. If we have an H+ and a water coming together, what molecule are we going to get? H3O+. So we really say that acids have a high concentration of H3O+, because anytime the H+ breaks apart in water, it likes to join up with water to make hydronium. Right? Now, bases, like NaOH, when they break apart, what are they going to have? What is that solution going to have a high concentration of? What? OH minus, yes, hydroxide. Okay, so it's going to have a high concentration of hydroxide. Now, what substance did we talk about that is neutral, that you drink often? Water. Okay, so water, sometimes we often write it HOH. So when water breaks apart, what two ions does it form? H+ and OH. All right, wait. Acids have the H+, bases have the OH. What? If something's neutral, that means it has an equal amount of H+ and OH. Because water, each time it breaks apart, there's one H+, there's one OH. How cool. All right. So there's a little background on it. So titration, again, helps us neutralize the acid and base, and it helps us figure out the molarity of an unknown base. So I want to show you a couple pictures of a titration, because we're going to do one tomorrow, but today we're just going to do the calculations, which I think you guys will be like, oh my gosh, Mrs. Connor, this is too easy. Give us something more challenging. And I'll be like, deal. Come tomorrow. Okay, picture. So first of all, I showed you that in the back lab stations, we have something called burettes. All right? They're these long glass measuring devices. It's like almost like a giant graduated cylinder, right, mounted on a ring stand. Right, at the end, it has a little lever that you can turn, and whatever liquid is inside the burette will go out into the flask. Right, so next class what we're going to do is we're going to put some acid in our flask, and we're going to have base up here in the burette, and we're going to start putting some base into acid. All right? What eventually is going to happen if we put enough base into acid? It's going to become neutral. We don't want to put too much base because then it'll be basic, but if we put just enough, it'll be basic. But if we put just enough, it's going to be neutral. Now, if I have a clear acid in a clear base, how in the world am I going to know when it changes from acid to base or acid to neutral? This is really hard. We're going to need something. We're going to need something called an indicator. It's called phenolphthalein. So we drop it in, and it helps us. It helps us out. It helps tell us, is it acid, is it base? Oh, that was anticlimactic. Bam! Phenolphthalein involves a pink color, so that's awesome. All right? When phenolphthalein is in acid, it's colorless, it's clear. When phenolphthalein is in base, it is hot pink. Ow, ow! All right, our goal, though, is not to have clear nor dark pink, right, because we want to neutralize it. So we want this very, very, very light pink. So our goal for our titration, we'll know that we're done when we have this beautiful light pink color. That means we've neutralized it. And it involves some calculations, and it's just fun because you get to try it out. When I was in high school, my first titration was like a disaster. It was like hot pink, and I was like, no, I ruined it. But then I had some practice, right? So when I got to college, I got one of these babies, and I was like, yes, I can rule the world now. So you take chemistry later. With this practice of titrations, you will get that feeling as well, hopefully. Maybe not, but we can dream, right? Okay, so let's get into the calculations. I'm done like geeking out about phenolphthalein and such. All right, so we have a new, slightly new equation. It's very similar to M1, V1, M2, V2. You remember that, the dilution equation? But now it's instead helping us out with acid-base. So Ma Va equals MbVb. What do you think A stands for? What? What do you think B stands for? Base. You're right, acid and base. Big M is our molarity, yes, and V is volume. Okay, so if you kind of read the description on page 173 of each of them, obviously M is the molarity, and then the V's are the volumes that we can read off of the burette, right? So they're going to give us the volumes here, but to next class, we get to read the volumes off our volumetric flask. Okay, so let's look at problem number 1. Like the other types of problems, I'm going to list out all my variables first and then start filling in the information. So the thing about these is we need to be able to recognize an acid and a base, right? Bases have what anion at the end? Hydroxide, and acids have an H at the front, H+. So it says completion of a titration determined that 14.5 milliliters of NaOH was needed to neutralize 10 milliliters of 0.10 molar HCl. Determine the molarity of the base. So which of these 4 are we trying to solve for? Molarity of base, Mb. It'll have molarity as a label. And then it says 14.50 milliliters of NaOH. Is that base or acid? Base, NaOH, it ends in OH, it's the base. Milliliters of NaOH. So then the other 2 values must be acid, because HCl is a, beautiful, Janet, it's an acid. All right, so it says 0.10 molar HCl, and then what volume of it do we have? 38.25. Sweet. All right, so now we just plug in our numbers and we solve for molarity. So Ma, 0.10. I'll leave in MB because we don't know it. That's our variable we're solving for.